Okay, so the start of this video, we're going to review what we just talked about, but that's good to hear it again. How to construct the incenter of a circle. We're actually going to talk about how to construct the inscribed circle, and we'll find the incenter first and then talk about how to get the rest of the circle. So to find the incenter, remember we need angle bisectors of each vertex. Really, it only takes two. We saw that with the perpendicular bisectors in an earlier video where if three of them are going to cross at one point, it's the same point where two of them will cross at. So let's just find two angle bisectors. Pick any two angles, and again, with a compass, this would be exact. So I kind of feel bad that I'm doing sketches, but hopefully we are kind of understanding the concept. So I'm going to start with this vertex right here. I'm going to bisect the angle. And try to accurately bisect the angle. So when I bisect it, remember that's giving me this angle congruent to that angle. Now I need to bisect a second angle. I'm going to work with this one over here. Bisecting that angle. Gives me two congruent angles there because I just bisected it. And where those two cross, it's creating the incenter. The incenter is the center of your inscribed circle. What we can do next is construct a segment from the incenter to any side. Now, the incenter, the center of your inscribed circle, any segment that I connect to the side of a triangle will be perpendicular. So if I can figure out perpendicular right there, let's find a perpendicular to this side. Oop, that didn't look very perpendicular. Oop. That looks more perpendicular. And then perpendicular to the third side. These points will be on the inscribed circle. And so then you can kind of see how, and if I had a compass, I could do this very accurately. But these are the points where the circle is going to touch the triangle. It's going to look something like that. All right, so let's move on to identifying and using the incenter of a circle. All right, if QP equals 3 times x plus 1, so here's QP, 3 times x plus 1, and RP equals 5x minus 3, what is the radius of the inscribed circle of triangle JKL? So there are some things we want to notice in our picture. We see that KP is an angle bisector and LP is an angle bisector. Why don't we make notes of some of these? KP and LP are angle bisectors. So where they meet, that is the incenter of the triangle. So they meet right here. That is the incenter. So just to connect that to what we were seeing before, from the incenter to the side of a triangle will be a perpendicular segment, and the inscribed circle would go through those points. So point Q and R, I know there's a circle that's going to hit through those. It would come down and hit through these like that. So because point P is the incenter, these two segments are going to be congruent to each other. Essentially, they're the radius of the circle, and whatever radius you draw in will always be congruent. So we know that PQ is equal to PR. And they told us what those segments are, so we can write an equation with that. PQ, well, they said QP is 3 times x plus 1 We'll set that equal to PR, which is also RP, 5x minus 3, and then we can solve. We'll go ahead and distribute the 3. 3x plus 3 equals 5x minus 3. Now we have x's on both sides of our equal sign, so let's get those to the same side. I'm going to subtract 5x from both sides. 3x minus 5x is a negative 2x. Carry down your plus 3. And then let's make sure we're aware this is a negative 3 that we're going to carry down. Solving for x, we will subtract 3 from both sides. Leaves us with negative 2x equals negative 6. And our last step is to divide by that negative 2, giving us x equals positive 3. So we did a lot of work. We had a lot of conversations. Did we answer the question we were being asked? We found the value of x. X equals 3. Is that the radius of the inscribed circle of the triangle? Well, no. The radius is QP or RP. So we're going to take that x equals 3 and plug it into either one. It really doesn't matter which one. Maybe I'll plug into RP since that's already simplified. We wouldn't have to distribute. So RP is equal to 5x minus 3. Now that we know what x is, let's plug in a 3. 5 times 3 is 15 minus 3. We're getting RP equal to 12, and that is the radius of the inscribed circle.